In our sky, there is one star known as Betelgeuse, often playfully referred to as Betelgeuse. It's a red giant star. If you placed it where our Sun is, it would extend out to the orbit of Jupiter. This star is enormous and very unstable, seemingly on the verge of exploding. We might be on the brink of witnessing a cosmic disaster of unprecedented scale. Betelgeuse, the red giant star at the edge of our galaxy, is sending alarming signals through space. Astronomers, using the James Webb Space Telescope, have found something deeply troubling about this massive object. Noted scientist Brian Cox has issued a serious warning. Are we about to witness a supernova explosion so massive it will change the night sky forever? Let's dive right in. In the vastness of the universe, stars are born, live, and die in amazing ways. Recently, one star has captured the attention and concern of astronomers and laypeople alike, Betelgeuse. This red supergiant star stands out in the constellation Orion. It is very large and very old. Its unique reddish color and fluctuating brightness have long been of interest, but recent developments have heightened the intrigue surrounding this cosmic giant. As we learn more about Betelgeuse, we may be on the verge of a crucial event in its history. But what might these changes mean? Are we witnessing the beginning of a cosmic spectacle of unimaginable scale? Betelgeuse is a stellar giant, approximately 764 times the size of our Sun. It is so vast that if it replaced our Sun, its surface would extend beyond Mars's orbit and engulf Mercury, Venus, Earth, and Mars. This immense size not only underscores the physical grandeur of Betelgeuse but also indicates its stage in the life cycle as a red supergiant. Betelgeuse is nearing the end of its life. It is expanding and cooling in this phase, which follows the conversion of hydrogen into helium in its core. As for Betelgeuse's age, this star is thought to be between 8 and 8.5 million years old. This might seem young in human terms but is very old in stellar terms. Over millions of years, it has undergone dramatic changes, evolving from a hot blue star to the red giant we see today. It is now in its final stage as a red supergiant. Stars like Betelgeuse change throughout their lives due to the constant pressures of nuclear fusion and gravity. Another notable feature of Betelgeuse is its reddish color. This red hue is due to its surface being cooler than that of many other stars, such as our Sun. The surface temperature of the Sun is about 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that appear red. This color is not just an aesthetic trait, it provides insights into the star's physical state and the processes occurring within its vast gaseous volume. Historical records, including writings from Roman and Chinese eras, suggest Betelgeuse was yellow about 2,000 years ago. By the 9th century, Arabic astronomers noted it had turned red. This shift in color over human history illustrates the star's evolution. Additionally, Betelgeuse's brightness varies over time, classifying it as a semi-regular variable star. Its brightness cycles every 400 days and also undergoes a longer 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and they may have been noted in Aboriginal folklore even earlier. What makes Betelgeuse particularly intriguing is not just its periodic brightness changes but also its irregular fluctuations. Unlike many stars with predictable dimming and brightening patterns, Betelgeuse sometimes deviates from these patterns, suggesting complex, less understood processes within its massive form. Recently, astronomers and stargazers worldwide were stunned by Betelgeuse's dramatic and unexpected dimming, now referred to as the Great Dimming. In late 2019, Betelgeuse, one of the brightest stars in the night sky and a prominent feature of Orion, began to dim mysteriously, losing light at an average rate of 0.01 magnitudes per day. By February 2020, it was at its dimmest. Usually visible even in light-polluted areas, Betelgeuse became noticeably fainter, a change apparent even to casual observers. Observing Betelgeuse is complicated by the time paradox. Because light takes time to travel, we see stars not as they are now but as they were in the past. For Betelgeuse, which is about 725 light-years away, we see it as it was nearly 700 years ago. This time lag makes predicting and monitoring rapid changes in its behavior challenging. The dimming event highlighted the difficulties of real-time astronomical observation and underscored our limited understanding of the vast, strange realms of space and time. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, along with her team, closely monitored Betelgeuse's dramatic dimming as part of a 3-year study to track changes in its outer atmosphere. They utilized the Hubble Space Telescope for this celestial drama, offering new insights into the mysterious processes occurring in this colossal star. Theories are now trying to figure out what this huge loss of matter means for the star's health and future. While astronomers are focused on Betelgeuse, the supernova SN 2023X is also getting a lot of attention and can be used to make interesting comparisons. This amazing explosion happened in Messier 101, which is also known as the Pinwheel Galaxy and is only 21 million light-years away. SN 2023X, which was found in May 2023, isn't just another supernova, it's the closest one seen in recent years, giving scientists a great look at the end of a star. It was like a cosmic coup when SN 2023X was found. Koichi Itagaki, an amateur scientist famous for finding supernovae, first saw this quickly brightening spot on the edge of Messier 101 with a small 0.35-meter telescope. As soon as he announced his discovery, the astronomy community got to work. From the surface of Earth to the Hubble Space Telescope in space, telescopes all over the world turned to watch this new supernova explode. The race to keep an eye on SN 2023X's light curve gave scientists important information about the explosion and the area around the dying star. SN 2023X's behavior was carefully recorded during the month after it was found. In just 5 days, the supernova went from being pretty dim to being very bright. It then started a more steady decline, dimming by 0.03 magnitudes every day. A study of the spectrum showed many bright emission lines, which indicate how strongly the growing supernova shock wave and the gas around the star were interacting. It wasn't just a star dying, it was a huge star falling under its own weight. As its nuclear fuel ran out, the outer layers blasted off the dense core in a spectacular core collapse supernova. What's really interesting about SN 2023X is the dense shell of gas that surrounded it. This made it much harder for the shock wave to escape from the middle of the star. There are 2 possible explanations for this dense material around the star. Either a strong, steady wind was blowing material off the star before it exploded, or the star had random explosions that threw material into space. In any case, the star is thought to have lost up to a solar mass of matter in the last 1 to 2 years of its life, which shows that its last moments were anything but peaceful. The main goal of research is to find the parent star of SN 2023X. Researchers have used a variety of methods and statistics to come up with a likely candidate, a red supergiant. By studying the specifics of SN 2023X's explosion, such as the features of its parent star and the processes that led to its final blast, astronomers can improve their models of how stars form and how supernovae work. These new ideas directly help us understand what's going on with Betelgeuse right now and how it might end up going supernova. They give us a better idea of what signs to look for and how to understand the huge red giant's complicated behaviors. But when will Betelgeuse become a supernova? Tohoku University researchers think that Betelgeuse may be in the carbon-burning stage of its life right now. This is the stage that stars usually go through before they die. Hideyuki Seo, who is in charge of this work, thinks that the star's core might collapse a few tens of years after the carbon runs out. On the other hand, scientists at Hungary's Konkoly Observatory think Betelgeuse is in an earlier stage of burning helium. There are different opinions, but most agree that Betelgeuse will likely be the next supernova in the Milky Way. However, this event might not happen for another 100,000 years. In the past, looking at supernovae has given us a lot of useful information about how stars die. In 185 CE, the first known record of a supernova was made. It was seen as a bright star that disappeared from the sky after 8 months. Since then, many important supernovae have been discovered. These include SN 1572, which was the biggest star ever seen in the night sky and could be seen from many places around the world, and SN 1054, which caused the Crab Nebula to form and could be seen during the day for 23 days. The most recent supernova seen in the Milky Way was SN 1604, which Johannes Kepler studied in great detail. Recently, supernova 1987A in the Large Magellanic Cloud was seen just hours after its light reached Earth. It was the first supernova to be seen through neutrino radiation and in all electromagnetic spectrum bands. These observations have been very helpful in making accurate models of how supernovae behave and figuring out what part they play in the formation of stars. What if all of a sudden the night sky erupted in a brilliant show of cosmic fireworks and the bright explosion of a star caught our attention? Imagine for a moment that the once familiar constellation of Orion had a new bright star added to it. Betelgeuse, one of its brightest stars, had become a supernova. What kind of effects might this amazing event have on Earth? Betelgeuse is about to go through a core collapse supernova, which is a type of explosion that happens when huge stars run out of nuclear fuel and can't support their own gravitational collapse. Core collapse supernovae are some of the most powerful and destructive events in the universe. It will take only seconds for Betelgeuse to go supernova, but it will release as much energy as our Sun does in its billions of years of life. Most of the energy that a supernova gives off is electromagnetic radiation, which includes X-rays, gamma rays, and visible light. A Betelgeuse supernova, on the other hand, would cause a spectacular light show in the night sky that we could see right away. For a short time, the blast would be brighter than the moon and it could be seen during the day. Imagine looking up at the sky during the day and seeing a second, much brighter sun appear for a few weeks or even months. Astronomers and people who just like to look at the stars would both be amazed by the event. But as interesting as it would be to see a Betelgeuse supernova, its real importance lies in the scientific questions it raises. Supernovae, especially those that happen when very large stars like Betelgeuse explode, are like laboratories in space that teach us a lot about how the world works at its most basic level. One of the first perks of watching a Betelgeuse supernova would be the chance to see up close the last stages of a star's life. When very big stars like Betelgeuse blow up, they send heavy elements like iron into space that were formed inside the stars. It is this process that adds the building blocks of planets, stars, and life itself to the universe. Scientists can learn more about how stars change over time, how elements fuse together, and how they help make new celestial bodies by looking at the spectroscopic signatures and the spread of these elements after a supernova. This information is very important for figuring out the universe's past and makeup. The visible light from a Betelgeuse supernova would be very bright, but the neutrinos that would be released are just as interesting. Neutrinos are subatomic particles that are extremely hard to detect because they don't interact with matter very often. In the intense environment of a supernova, however, huge numbers of them are produced. These hard-to-find neutrinos give us a unique look into the heart of a dying star. They can tell us about how the core collapses, which helps us understand the basic forces and particles that are at work during a supernova explosion. Finding and studying these neutrinos would be a huge step forward in science, and it might lead to new information about the universe's harshest conditions. The discovery of a Betelgeuse supernova could also change how we think about the expansion of the universe and the mysterious force called dark energy. In the late 1990s, scientists looked at distant supernovae and found that the expansion of the universe is speeding up, not slowing down as they had thought. Because it is so close to Earth, the Betelgeuse supernova would be a good place to collect data on the rate of expansion of the universe and the role that dark energy plays in driving it. It might help us better understand these basic ideas about the universe, and it might even lead to new mysteries about the universe's structure and fate. What could happen on Earth if there was a Betelgeuse explosion, though? Is the world in danger? Because we are so far away from each other, this is not likely to happen. 1 light-year is about 5.88 trillion miles, which helps you understand how big our universe is. At 725 light-years away, Betelgeuse is more than 4,267 trillion miles away from Earth. There is a certain amount of cosmic shielding because of this huge distance, and it is very unlikely that the explosion itself will harm Earth directly. Glad you watched this space news unfold. The movie now showing on your screen is so crazy that you won't believe it. Take a look. To look at the huge star, these observations gave a new look into how a variable star like Betelgeuse works. Variable stars regularly get bigger and smaller, which causes changes in how bright they are. Researchers were able to look into the layers above the star's surface, which were heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. More study of the Hubble spectra, which were taken at different times in 2019 and 2020, helped figure out how fast things were moving in the upper atmosphere of Betelgeuse. The spectra were mostly made up of magnesium-2 lines, which show what the star's atmosphere is like. The studies showed that things were moving from the star's surface into its atmosphere at about 200,000 miles per hour. This hot, dense stuff finally reached millions of miles away from Betelgeuse. It was the start of the dust cloud that made the star less bright during the 3 months of the outburst. Dupree and her team thought that about twice as much material as usual from Betelgeuse's southern hemisphere was lost. While all stars lose mass over time, Betelgeuse's loss was especially noticeable because it happened at a much faster rate than the Sun's. Astronomers talked about whether this event could be a sign of a supernova explosion because of how big this mass release was and how dim it became afterward. Being only about 725 light-years away from Earth, Betelgeuse adds to the mystery because any explosion like this would be visible from Earth and give people a rare chance to see a supernova up close. But the question still stands, what does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is about to happen, or is it just a one-time event in the star's long and complicated life? Several ideas were put forward to explain this quick change. One popular theory suggested that it was a stage in the process of a supernova explosion. This idea caught on because most people think that Betelgeuse is almost done with its life. Another common idea is that dust, maybe from the star itself, is blocking our view. It is known that Betelgeuse and other red supergiants lose material, which could build up into a dust cloud thick enough to block our view of the star's light. A third idea looked at how changes in the star's photosphere, the visible layer on the outside, might affect how bright it seems. This puzzle was solved by using a lot of different observational methods and in-depth analysis. Spectroscopic studies showed that Betelgeuse's effective temperature dropped, suggesting that the star may be dimming because of a big dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea, indicating significant changes on the star's surface. In the end, the Hubble Space Telescope, which is humankind's watchdog in space, helped us figure out what was going on with this strange event. Hubble's views showed that the dimming of Betelgeuse was probably due to a large amount of hot matter being thrown into space. This material formed a dust cloud that covered some of the star's surface, reducing the amount of light that reached us. It was thought that the dust cloud was made of very hot plasma that erupted from a big convection cell on the star's surface and moved through its hot atmosphere to the cooler outer layers. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic studies, which began in January 2019, were very helpful in piecing together the events that led to Betelgeuse getting darker in the months before the dimming. These studies showed signs of dense hot matter moving through the star's atmosphere. Several ground-based telescopes also observed the star getting less bright in December 2019, especially in its southern half. The material that was initially brighter than the star itself moved outward and cooled, turning into a dark cloud. The idea was that this outflowing matter and the dark cloud it created were what caused the star to dim suddenly. This explosion was truly massive and put Betelgeuse at the center of astronomical studies. The star ejected about 400 billion times the mass that is usually expelled in a normal coronal mass ejection. This material, thought to weigh several times as much as the Moon, was significant for both Betelgeuse and our understanding of how stars work. But what does such a huge explosion of matter mean for ideas about Betelgeuse and supernovas in general? It has huge implications for theories about supernovae. Red supergiants like Betelgeuse are thought to lose mass at a fairly steady rate before they explode at the end of their lives. However, the size of this ejection calls this idea into question, suggesting a more turbulent and possibly uncertain end of life for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion in a few thousand years? New studies speculate on when this might happen, suggesting it could occur sooner than previously thought, perhaps in just a few decades. Another important piece of the Betelgeuse puzzle is the concept of bow shock. This huge star moves through space at about 67,000 miles per hour compared to the surrounding interstellar material, creating a bow shock similar to the wave created by a ship's bow. This effect occurs when the star's outer layers interact with the gases and dust in the space around it. This bow shock not only provides information about Betelgeuse's current state but also helps us understand more about stellar evolution and mass loss. What about the star's past actions? It has been observed that after the release, Betelgeuse's surface cooled and became less dense, indicating the star is still unstable years later. Hydrodynamic models show a link between the star's convective activities, the mass ejection, and the subsequent change in pulsation mode. This constant instability raises questions about the internal processes at work. Additionally, Betelgeuse's mass loss rate is much higher than that of many other stars, suggesting complex internal forces at play. The forced pulsation contributing to this mass loss is limited by energy loss through shock heating and mass ejection. These observations indicate that Betelgeuse's life cycle is very dynamic and not always predictable, prompting scientists to reconsider their models of stellar evolution. With all these significant changes, one might wonder if Betelgeuse is about to go supernova. The question is critical to astronomers. While the exact timing of such an event remains unknown, the recent unusual mass ejection has shifted the discussion, leading many to believe that the end might be closer than previously thought.